Okay, so the last class we have seen using interrupt, that is external interrupt we have seen using interrupt like we have done some simple experiment. So from external interrupt, like you connected one button, whenever you press button the interrupt will be raised, and when interrupt is raised, what happens in the program? Control will be transferred to the interrupt vector table. So sorry, interrupt service routine, ISR. Okay. So it will go and execute the ISR, and then it will come back to the regular main function execution. Okay. So now what we are going to discuss is when interrupt happens and when the interrupt is executed and when it is coming back to the main. In between what all happens. So we are going to step down one more depth, and we are going to understand. That is what now we are going to discuss. So how interrupts are processed. Got it, right? So when interrupt, so whatever it may be the way of interrupt, whether it is an external interrupt or internal interrupt, the process of the interrupt internally, how it is processed, it is going to be like a say. So how interrupt is processed? Interrupt request. First thing is from external device or internal request from internal like a peripheral or external peripheral, interrupt request is coming. When you press button, the interrupt is requested. Got it, right? So interrupt request. Interrupt occurs from internal or external sources. That is the first step. Clear? Next, interrupt processing. Microcontroller, MC stands for microcontroller. Microcontroller continuously checks for pending interrupt request and it sets the corresponding flag. Okay? No. So, voice will not be recorded. Fan. Okay. So, microcontroller continuously checks for the pending interrupt request. It means for example, when interrupt is coming, already there is a possibility that the pending interrupt will be there in the microcontroller, because see one interrupt is right now it is processing. When it is processing, some other interrupt comes. Okay, as of now you may not be able to relate, but you assume. So one interrupt came and that interrupt is executed. That interrupt service routine is in execution. At the same time, some other interrupt is coming, so you will not able to process the new coming interrupt. So that interrupt will be kept in the pending list. Okay. So similarly, whenever interrupt is coming, first what the microcontroller will do, it will check the pending list. If already some other interrupt in the pending list, the new coming interrupt he will not able to process. Correct, right? Because already somebody else in pending. So that time first he has to check the list, pending list. If no other pending interrupt request is available, then he will take the new coming interrupt. Everybody able to relate, right? So that is the reason microcontroller continuously checks for the pending interrupt request and it sets the corresponding flag. So which interrupt has come or which interrupt is going to process, only that particular interrupt flag you will make it as a 1. So already yesterday last class we discussed, for every interrupt there is a one interrupt flag. That flag automatically it will be set to 1 whenever that interrupt is occurring. For external interrupt, what is the flag? INTF. So INTF is the flag for external interrupt. So whenever external interrupt is happening, that flag will be set to 1. So here what it happens, when interrupt is happening, it will check the pending list. If no pending list, then this particular interrupt will be processed. So as a first stage, that particular interrupt flag will be set to 1. If some other interrupt is in the pending list, that interrupt flag will be set to 1. Got it, right? So which interrupt is going to process, that interrupt flag will be set to 1. But other interrupt, if something is kept in pending or something is like a still just now it came, that all flag will not be set. Which is it is going to process, only that interrupt flag will be set to 1. Getting right? So interrupt is coming, microcontroller is checking on the pending list, and which interrupt is going to process, that flag is setting to 1. That's the second stage. If the GIE is not enabled, it will ignore that interrupt request. Some interrupt is coming, but for that that time the GIE is not enabled, now then that interrupt will not be considered. You will just ignore it. Already I told, right, last class, any interrupt now first you have to enable GIE and PIE, peripheral interrupt enable, and global interrupt enable, both should be enabled. So whenever interrupt is coming, first thing is like it will be checked to the GIE. If it is enabled, then only it will be considered. Otherwise, like it is ignored. Also checks for the high or low priority level. For example, already there are some pending interrupt. In that, if now new interrupt is coming, it will check which interrupt is having high priority, which interrupt is having low priority. If some interrupt coming, the incoming interrupt is already having high priority, then the pending interrupt, then the new incoming interrupt will be processed. Again, it is not applicable in all microcontroller. Some microcontroller comes with the features that it will have high priority interrupt, low priority interrupt, medium priority interrupt. But this controller is not having that features. All interrupt is having like a same level. So in this case it is not applicable. But some case it is applicable, that is it depends on the controller to controller. If that controller is supporting high, medium, low, like that priority based interrupt, then once the interrupt is coming, it will check what is the pending interrupt, what is the incoming interrupt, among this which is having high priority. So that interrupt will be processed first. That flag will be enabled as a 1. Clear? Again, it depends on the microcontroller, not applicable for all microcontroller. This microcontroller doesn't have that feature. Clear? So also checks for the high or low priority level if applicable. High priority interrupts can preempt low priority interrupts. Nothing but high priority interrupt is like a preempter, means like that is replacing the low priority interrupt. Got it, right? So like you can assume whenever like we are in a queue for like a temple, some like the celebrity or some like the high profile person is coming now, so they will make us to wait. Let them go and visit, and then once they went, then they will allow the common people. Correct, right? So it is same. When already low priority interrupts in the waiting also, high priority interrupt comes, again that low priority interrupt will be made to wait, the high priority interrupt will be given, and once it is done, then the low priority interrupt will be solved. Clear? Okay, that is second stage. So interrupt comes, and how the interrupt is processed, it will be checking the pending list, it will check the like GIE, and it will check the priority level if it is applicable. Clear? These are in the second stage. Next, context saving. So now interrupt has come. When interrupt has come, it is already selected which interrupt it is going to process. That interrupt flag has made as a 1. So next thing is like now, for example, in main, now this is your ISR, interrupt service routine. Okay. So you have your main function. Got it, right? So when program is executing right now here, now he is supposed to move to this ISR. Correct, right? Interrupt coming means it will move to the ISR. So when he is moving to ISR, what he is supposed to do is, now your microprocessor or microcontroller, okay, you take any situation, microprocessor or microcontroller is executing this particular line for now. After executing the ISR, again he has to come back and he has to execute the next line of this, right? That is the like expected result. See, right now he is executing, assume that like at 15th line of your code. Once the interrupt is coming, now he is going to the interrupt service routine. After executing interrupt service routine, when he is coming back, he has to execute the 16th line, 16th statement, right? So that is the expected context. Okay. So context is nothing but right now he is in particular flow of execution. That flow is maintained in this microcontroller. So which line is executing, what is the current state of that registers, what is the value of that particular variable. So all of that it is maintained in this microcontroller or microprocessor. So in microprocessor, okay, microcontroller, instead of microcontroller I will explain with you microprocessor. In 8086 microprocessor, already we have discussed, there are few set of registers, two major type of registers. What are the registers? Special purpose registers and general purpose registers. So what is the purpose of that register? Those registers, okay, assume that like a special purpose register. In special purpose register, what are the registers are there? You have port segment register, stack segment register, data segment register, and instruction pointer, correct? So those all register is maintaining this particular program in the RAM, which particular memory location it is available, and exactly which instruction it is executing now. Got it, right? And similarly, when it is executing that particular instruction, those instruction related information, those instruction related data is stored in this general purpose registers. Got it, right? So it is right now completely, it is maintaining this particular program related details in this. Now from this flow, you want to go to the different flow of execution. Got it, right? See, you can relate like this. For example, like a morning I am taking a batch, I am taking C programming. So let's take like I am taking like a functions related topic. And the evening like I am taking this microcontroller class. So whenever I come to the microcontroller class, my mind context should be in the controller. Yesterday I talked and what I am supposed to talk today. Tomorrow again, like when I am going to the C programming class, again I have to set back what yesterday I talked in the functions and what I am supposed to talk today. Correct, right? So my mind will be set according to that particular context. Context is nothing but what is that situation. For that situation, my mind will be tuned. What is right? So when I am going to that class, I will be handling that particular flow. Again, I am moving one stage from function one class to other class I am taking. Again, I am stopping that class. Evening I am coming to this class. Again here what I am taking, interrupt I am taking, or like whatever next class is there. So here I am stopping. Again tomorrow morning I am going where I stopped. Again I have to continue back. Correct, right? This is the flow is expected. Similarly, in microcontroller also or microprocessor also, right now it is executing one program. So from here he is stopping and he is going to this. It is going to the different flow of execution. When he is going to different flow of execution, after completing that flow of execution, again he has to come back and he has to continue where he stopped. From there he has to continue. Correct? That is the right expected result. Okay. So is right now where he is executing, that all details is maintained inside that microprocessor in that general purpose register and in the special purpose registers. So those all register related details will be taken one copy and it will be stored. Got it, right? That is nothing but saving the context. And where this ISR is present, that ISR related information, that starting address of the ISR, it will be loaded into this microprocessor so that this microprocessor will be able to execute this microprocessor. Sorry, it will be able to execute this ISR. Now, once he has executed all of this, now he has to come back to the microprocessor has to start execute from here. Whether it is microcontroller or microprocessor, the functionality is same. Okay, just you relate with anything. So once this is completed, now he has to start execute from here. How he will start execute? Already we saved the information. Those all saved information, now you are loading it here. Once it is loaded, now again he will get this flow. Got it, right? So he will start execute from the place where he stopped. From there he will be able to execute. He will not miss any context because everything we already saved. Whatever he is maintaining the details, these all things like we saved in some place. From that place again we are loading so that again he will be able to continue the execution. Clear everybody? Okay. So that is nothing but context saving. Context is nothing but what is the current state of this the particular flow execution, that all flow is maintained here, that context is saved in some particular memory. Once again here you want to go back, means again the context is saved here, so that you will move back to the same context, same flow of execution. Okay. So context means very simple way you understand. You all five guys are like talking about like okay, you're talking about some particular topic. Somebody else is coming and talking like a completely different topic. Okay. So then people will say, hey, come to the context. What we are talking, you talk related to that. That is nothing but context. Okay. So it's a very important topic. Context switching, context saving, these all like you need to understand. So context saving is nothing but when interrupt occurs, the microcontroller automatically saves the current execution context. So what is the current flow of execution? That all will be saved. And it includes what are that information it is saving. That is nothing but program counter, some status registers, flags and other status bits. So these all information from the microcontroller, it is saved into some memory. That is, these all information only is nothing but it is a context. Is everybody getting this? Okay. So interrupt is coming and he is checking any pending interrupt is there, any priority is there, GAE is enabled. If these things are okay, that particular flag is made to 1. After that, like, he decided that which interrupt he is going to process. So right now, before taking that interrupt, what he is doing, right now the microcontroller is saving its own context in some memory. Clear? This is third stage. Next, interrupt vector table. Microcontroller has predefined the interrupt vector table. It is nothing but a table which is maintaining what are the interrupt you are. So in this microcontroller, as of now we discuss about only one interrupt, but there is a possibility that like you can have around 10 different interrupts. One is external interrupt, ADC interrupt, timer interrupt, UART interrupt, like that. So many interrupts can possible. That all we are going to discuss in the upcoming classes. So which interrupt is coming, and when that interrupt is coming, which line of code he has to execute. Interrupt vector table is nothing but you assume that like a small table, like our the book index page. So chapter 1, what is the page number? Chapter 2, what is the page number? Chapter 3, what is the page number? We have an index page. Same like interrupt vector also. For external interrupt, what is the address? He has to go. For timer interrupt, what is the address? He has to go. For like a ADC interrupt, what is the address? Like a he has to go. So this address is nothing but your interrupt vector table. Service routine. Okay. So when this interrupt comes, the flow you want to execute on the 2000 line. That is your ISR. When external interrupt comes, what line you want to execute, what address you want to execute, that is nothing but your ISR, right? Where your ISR start, that address will be maintained in this interrupt vector table. So this interrupt, this address, this interrupt, this address. That is nothing but IVT, that is interrupt vector table. Clear everybody? So in microcontroller, it is already one predefined table is there. Whether you have only one interrupt or you have 10 interrupt, that table will be there. So one interrupt comes also, it will go to that particular table. In for that interrupt, what is the address he has to go? He will take that address and the control will jump to that address and then he will start execute. Because already we saved all information. So now he will directly go to that address and he will start execute that particular ISR. Clear? Okay. So microcontroller has a predefined interrupt vector table. When an interrupt occurs, microcontroller jumps to the the address specified in the IVT for particular interrupt. Clear everybody? So starting address of the ISR, that is, this address is nothing but starting address of your ISR. Till 4, everybody clear? Any confusion? Interrupt comes and it is checking if any pending interrupt is there, and is GAE is enabled, and is there any priority is applicable. This all checking happens, and then if these things are okay, he selects which interrupt he is going to process. If already pending is there, then he will select. If no pending, then directly whichever interrupt comes, that interrupt only is going to be processed. So that interrupt flag will be made to 1. And then he is going to save the current state, current context of the microcontroller, that is saved. That is context saved. After that, he has to jump to that particular ISR. So ISR where it is present, he goes to the IVT, interrupt vector table. In the interrupt vector table, okay, this interrupt came, this is the address I want to go. So he will take that address and he will go to that flow and he will execute that ISR. Clear? Next, executing the ISR. As we mentioned, it is already taken the address and it is coming here. Clearing the interrupt flag to prevent the immediate inside the ISR what we are doing. So it will do whatever inside the ISR, whatever functionality is that you will execute. Also what you will do, you will make that flag to 0. Got it, right? So you will make the flag to 0. Actually you are doing what you are supposed to do in that ISR, that also you are doing. Along with that, like you are clearing the flag to 0. Because if this flag is, you are not making it a 0, that will be still remain as a 1 only. Got it, right? So there is a possibility that again and again this ISR will be getting executed. To avoid that, like we are making that flag to 0. So clearing the interrupt flag to prevent the immediate re-triggering. Re-triggering means again and again and again it is executed. Other interrupt specifies time critical task. Okay. Okay. See. Okay. See, in this particular microcontroller, you have like only one ISR. Okay. But it depends on the controller to controller, microprocessor to processor. But in this controller, you have only one ISR. Any interrupt comes, the control will come to the same ISR. See, assume that like right now, external interrupt came. So your controller is coming here and it is checking if you have one if condition, you check here in ISR, you have one if condition. If INTF is equal to 1, you will do some certain operation. And then you are making the flag to 0. Right? So, if external interrupt comes, it will come here and that flag is 1, so it will go on to do the necessary job for that external interrupt, what it is supposed to do. Correct? After doing that, it is making that flag to 0. Now, assume that some other interrupt comes, timer interrupt. So that time also it will come here only. And that time, for timer interrupt, there will be one flag. And that, there will be one function. Okay, so your ISR will look like this. Void interrupt something ISR I am giving. If INTF equal to 1, you are doing some operation related to the external interrupt. If TMR0 interrupt flag equal to 1, you will do the TMR0 related operation. If ADC interrupt flag equal to 1, then you will do the ADC related information. Understand clearly? See, one single ISR. When ADC interrupt comes, it will come here. Got it, right? ADC interrupt comes, it will come here. That time it will check this if condition. The if condition will be true or false? False. Why false? Because this flag is external interrupt flag. Whichever interrupt comes, only that flag will be 1. So this flag obviously it is going to be 0. Again, it will go and check this flag. Timer flag. Will it be 1 or 0? 0. Again, this is also false. Next, it will go to the ADC interrupt flag. Will it be 1? Yes, because the interrupt has like a ADC interrupt. So this will be 1. So condition is true. It will do the necessary operation for the ADC related information. And also end up the like a condition, you are making AD interrupt flag equal to 0. Got it, right? Now assume that now external interrupt is coming. Again it will come here. Now it will check. Now this condition is true. It will do the necessary operation. And here also end of this condition, you are making INTF is equal to 0. Assume that if I have not made it to 0, got it, right? When ADC interrupt came, I hope everybody following this. This is importance of flag. I am just discussing what is the usage of this flag. So when ADC interrupt comes, that time it is executed. Assume that if I am not making this flag to 0, okay? Now it is fine. That flow is fine. When next interrupt is coming, like let's take a external interrupt, that time control will come here. That time this condition will be true. It will execute this, and then it will go this condition. This condition is false. This condition, it will be true because I have not made it to 0. So when other different interrupt is coming also, my the previous interrupt code will get executed because I have not cleared the interrupt flag. So that is the reason every time whenever you are executing that particular interrupt code, at the end of that code you have to clear that particular flag. This is very important. If you are not clearing it, next time it will affect, or like it will execute the different code also. Is it clear? See, again it depends on the microcontroller. See, in this microcontroller only we have a same interrupt service routine code. But if you take the other microcontroller, for each interrupt there is one separate ISR. Other interrupt there is a separate ISR. Other interrupt there is a separate ISR. So in that case, in the interrupt vector table, you will have different address. But in this case, in interrupt vector table, you are going to have only same address because all interrupt is like for all interrupt the ISR is going to be same ISR. So everybody getting? I think post lunch people are feeling. You want break? These are all full theoretical. People are feeling like it's a good story. Okay. Now it's because anyhow even if it is going another 10-15 minutes extra also, that is not a problem. But finally I want you to receive it. That whole content you want to receive it. Now it is 3:22 now. Let's come back by 3:40. Till 3:40 you guys take break and come back.